Trig graphs. We'll have a look at sin x. Sin x goes through 0. It's got a maximum and minimum of 1 and minus 1. Its maximum hits at 90, and then every 90 interesting things happen. Therefore we can label the axes 90, 180, 270, 360. Going the other way it's exactly the same, minus 90, minus 180. It's an odd graph, so it's got a nice symmetry going on in it. A few things to note with the sine graph is that sine of x equals the same as sine of x plus 360. In other words, after every 360, everything repeats exactly. So if you've got one answer, you can add 360 on, you've got another answer. Sine of x equals sine of 180 minus x. So within that first little kind of hump, you've got a nice kind of symmetry. So that however far you are away from 0, you're the same distance back from 180. And sine of minus x equals minus sine of x. That's the odd feature of the graph. It's the fact that if you look at everything, it's got that kind of weird negative symmetry about it. We'll have a look at the graph of cos. Very similar to the graph of sine. Maximum at 1, minimum at minus 1. Again, every 90 is important, so 90, 180, 270, 360. It's the sine graph that's just been shifted left 90 degrees. Most of the things to note are kind of similar ideas. So cos of x is the same as cos of x plus 360. After 360 everything repeats. Cos of x equals cos of 360 minus x. So instead of it just being the first hump that's important, it's the entire kind of 360 that you've got going on. So however far you are inwards, it's the same back from 360. But cos is an even graph, so cos of x is the same as cos of minus x. So it's got a perfect symmetry in that y-axis. Lastly, we'll have a look at tan of x. Now tan of x has got this kind of weird swooshing kind of action going on. It's also got these dotted lines. These dotted lines are called asymptotes. What that means is that at these points it doesn't have a value. It's a disconnected graph. It goes all the way up and then it starts again at the bottom. Again, it's every 90 that's important with these. So the asymptotes are at minus 90, 90, 270. And it cuts the axes at minus 180, 0, 180, 360. A few things to note with this. It's not the 360s that it's important. Tan of x is the same as tan of x plus 180. It is copied every 180. Again, it's an odd function, so tan of minus x is the same as minus tan of x. And that's pretty much it for the trig graphs. Thank you.